up here and make sure it's working. And it looks like people are coming in. Okay, we should be good to go here. All right. Let me just make sure there's also a stream going on. I want to just make sure that's coming through. And I believe it is. So hopefully all that's going through here. Let me just make sure. Going through. Okay, cool. All right, great to see everyone here. We'll give everyone a few more minutes to get started and jump in. If we haven't met before, my name is Matt. I head up all of our customer education here at Wherobots. And today we're doing the second in our series around using our new MCP as well as our AI coding assistant tools to build some different projects using kind of all these AI agents and things like that. So today we're kind of doing some real estate sort of site selection and kind of trying to do that with some more complex data sets and use that to pick out some very specific locations and things like that. So that's what we'll be doing today. We're going to, kind of go through, show you how to do that, get set up and everything like that, and, actually start using these tools together. If you are not familiar with some of the tools, we'll also give you a quick introduction into what they can do and how you can use them. And more importantly, how you can really start to actually get started with this stuff and take it forward from there. So that's what we'll be doing today. If you have any questions at any point, you can go ahead and ask those right in the chat here. So you can use the chat to do that. You can also do that. There should be like a Q&A as well if you want to use that. Either one will work. I'll keep an eye on both of those so I can see that those are coming through and we'll go from there. So that's our goal for today. Our goal is also to say, if you wanted to take this forward and get started, you can do that. You can sign up for an account that gives you a 30-day trial with lots of credits to actually start to do this stuff on your own and build as you go along. So that's what we'll be doing today, and we'll get started from there. We're really just kind of jumping in and go from there. So before we get started, I also like to see kind of who's who's joining from where. So if you wanted to just let me know in the chat where you're joining in from, I always like to see that to see where people are coming in. So you should be able to drop that in the chat. If you have any issues, let me know. But if that's all set, we can go ahead and get started here. So if you haven't used Wherobots before, you can actually get started right from here. There's a few new things that if you've used us before, maybe you've used Wherobots, tested it out, things like that. There's a few new things I want to point out, and primarily these are the tools we'll be using, which is first our VS Code extension. So previously, you had to log into Wherobots, and you can start notebooks this way through the cloud. You can still do that if you want, but now you can connect runtimes directly from from your VS Code extension and actually run your code directly from your laptop here. Looks like people are starting to add in. Yeah, North Carolina, Texas. Yeah, good to meet everyone here. So great to meet you. The key is that it's actually pretty easy to get started with this. So what you can do here is actually just go to the VS Code Marketplace and install the Wherobots. This will install your MCP, will install the ability to build runtimes. Yeah, Washington, D.C., California, Poland. Good to meet everyone. And you can just install this right in your VS Code. Makes it very easy to get started, and then you can go from there. We also have a few other tools here that allow you to do, install and connect to Wherobots. You can run your AI assistant notebook, depending on what AI assistant you're using. If you're using Cloud Code, if you're using other things, you can use some different pieces there. You can actually build and run complete jobs here directly from this. So if you've created an analysis, you built into a notebook and you've tested it out, now you want to run this as a repeatable job, it will run that process for you daily. And then more importantly, then you can also kind of connect our MCP into a variety of different tools to build full projects based off of that. But really it centralizes everything into one hub, that being VS Code. It allows you to very easily start to ask questions and explore the data that you have. It allows you to then turn that into a production job to run things through on a repeatable basis. And then from there, you can take that data forward and do a number of different things with it, which we'll show you in a minute here as well. So that's what gets started there. Now, there's two tools that I want to call out very specifically. That's our MCP server, as well as our CLI. So if you go here, and this documentation page explains it really well. I'll just share this here as well in the chat, and then I'll also make sure to share the VS Code extension so you can get that started. You just have to go to docs.wherobots.com. It's right at the top there, so you can see that here. Let's go forward here and talk about the CLI versus the MCP. So the MCP connects into your data catalog. I'll explain what that is in a minute. It can actually build and generate spatial queries, and it has access to our complete documentation. So if there's complex spatial SQL, if there's raster spatial SQL, it will generate all of that for you. And I think this is really important because it's very easy to actually start to build these queries here and do that with this. The key is that, let's imagine that you're asking an MCP a specific question about a very, very small area, maybe your neighborhood, right? If you wanted to do that at a small scale, it's very easy to do that. And a lot of MCPs will connect in via APIs and be able to handle that for you. Oops, let me just fix that here. Bumped my mouse. On the flip side, if you wanted to do that maybe at a country level scale or even a state or province, you'll need more spatial compute power to do that. That, depending on the system you're connecting to, might work fine, or it might completely fail and it might cause issues. Or if you're connected to maybe a system that requires you to pay per query, then you're really in trouble because you're running a very complex large scale analysis and stuff like that. With Wherobots, we allow you to give access to runtime. So you pick your runtime size. It will run that for a specific period of time. If it's a minute, it'll get billed for a minute for that time span. If it's not, it will just run through that. But it's very predictable to know what you're getting on the back end there. The other underlying piece is that our underlying system is very efficient to do the spatial queries, and you can do that and get the full advantage of that with our spatial queries and our data service in the back end. It also allows you to understand your data quality. You can inspect schemas, run preliminary analysis, and then actually, understand what the features are under the hood, and then actually build full-scale notebooks with this as well, which is, I think that's probably the most powerful thing I've been able to do with this. Now, the CLI allows you to basically create jobs. You can, use the MCP to turn this notebook into a production job and turn that out. You can manage workloads, so you can see what's running and manage them that way. You can access the full API and automate workloads here. So you don't have to run the CLI commands yourself. I generally use our AI agent to do that and build those things out. So it allows you to do that in a very repeatable, manageable scale and go from there. So that's what I think is very cool about this. What that looks like, and you can kind of see here, is that in the data hub, this is some of the data that you have access to. Everyone has access to the open data. If you sign up for a trial and upgrade to the pro version of Wherobots, you get access to all of these data sets as well. But for example, we get the full Overture Maps data set out of the box, right? This is global data. And just for context, we can just look at the buildings data set. And you can see here, we have the versions going back, all of the different versions they've released. But for this one, there's 2.5 billion buildings in the entirety of the world. And what our compute allows you to do is, if your analysis starts in one area, say in Phoenix, and then moves to another area, maybe, that's in Bangkok, you can just immediately jump that over. And if you have data coverage there, it's global data, and there's no problem to do that. So you can ask those things at any area of the world, and you can also scale that up. Maybe you want to go to the entire state of Arizona, or maybe the entire Southeast United States. You can do that, and the MCP will help you scale that and write the queries and make that very efficient. So that's one key piece. We're also working on adding some more open data sets, which I'll showcase in a minute, and allow you to do that. But the key is that we're doing this all through prompts and asking questions and using this as our backend to understand and discover and see what's in the data. So that's where we're going to get started today. So I'm just going to zoom in here so everyone can see, and then we can kind of start to see where we're at with what we built today. So I built some analyses here, and I want to actually start to run these. I've run these already, so you can kind of see what's happening under the hood here, and how this is actually getting built out, right? So the first step is, like, I'm looking and trying to understand what parcel data is available in the Wherobots catalog. I'm looking for zoning valuations, opportunity zone designation. So you can see that I ran that here, but I maybe didn't copy the W, but I think it was smart enough to figure that out. So it's looking at what's available here. It's actually going to go through our documentation and see what's available. It's going to look at the catalog hierarchy. So this is all that data you saw before. It's going to scan that entire catalog and go from there. You can even give it specific data sets if you want to call those out to say, I want these specific data sets and things like that. You can see all of those and check what's available there. And it's going to go through that. And you can see here, it identified some sample data that we have available. This is from a partner of ours called Regrid. They provided some sample data, so you can check that out. It tells you things about the zoning, what's in the data set. Here's the valuations. Here's what is basically available for you here. Tells you if it's in a qualified opportunity zone, which in the US is a very specific designation for that data. And then there's some bonus stuff for later step for FEMA flood zone designations and stuff like that. So we can do here is you can actually see what's data there is. And then it can read the isochrone drive time data. Now we also have isochrone drive times around POIs. So we have that enriched here from the Overture Maps places. You can see we have that at a 5, 10, 15, and 20-minute drive time isochrone. It's actually in taking a look at my prompts already, so you can see that I want to do a 15-minute drive reach for the hospital at some point. So it is aware of that. And then it has all of the other data from the Overture Maps data set. So I'm just kind of building out what I want to do here and just do some first exploration of the data to see what's available. These are all open data sets that are there, and we're previewing a few open data sets that we're bringing in soon as well. And it will tell you some different things here. This is a sample query. So it's already building some logic about once it gets into the data query, what it wants to do later down. And then it says, it wants to move into the demographic block groups data. And this is some data that we're working on making available. You can see here, I've pulled in a block group summary across 132 columns at the census block group 11 in the United States. And it has things like household income, income distribution buckets, housing market signals, population and age, education, so forth. So you just can see what you have here and then start to build your analysis forward and kind of scale that up. So you see there's commute patterns, household composition, mobility, how people are moving in between these different areas and stuff like that. And then the digital access here. So there's, all these different data points here that we basically pulled. We're making the full census data set available. It's like 3,000 different measures. These are like 130 that we kind of cherry picked that are generally used for a lot of different things. So you can see what's there. So there's a quick question. What was the setup process to get the Overture Maps data in chat form in VS Code? It was literally just this prompt here and these prompts. So I'm just asking that here. What's happening under the hood is if I go back to this Overture section and the query here, you can see here it ran describe here. It's looking at this catalog of what's available, and then it's returning all the different information about the data set here. We're not running any queries yet, to be clear. We're just connecting into our data catalog, which requires no compute. We're only running exploration here to see what data is available. And that describe whereabouts catalog connection from our MCP allowed us to do that. So that's what's happening there. Okay, so we'll kind of keep going here. We take a look at this data here and our compute patterns and so on and so forth. And then it's building some of this spatial join logic that it's going to be using later on as well. So then we can take a look at what we have in terms of historic storms data. It's doing the same process here to take a look at what's available. So it's taking a look and pulling that in. And then you can see here that in this case, it's actually pulling in some of the data that it already pulled in from the MCP. So it's kind of helping us do that without kind of recalling the service every time. And this is using Copilot, to be clear, if anyone had any questions on that. So this is historic NOAA storms. This is another data set we're working on onboarding. It's basically the full severe weather data inventory. And we've split that out into there's tornado signatures, mesocyclones, aka thunderstorms. There's hail probability, storm cell structures, storm reports, stuff like that. And then pre-tiled versions for rendering. So you can see all the data that's available. There's current warnings, warnings history, forward-looking weather. We have some, we're testing out how we can bring in like forward-looking, daily forecasts from NOAA as well. And then there's other risk layers here like weather events, wildfires, things like that. So again, the whole idea here is that if you have well-structured data, it's spatially organized and it has the right sort of structure in it for all these different pieces, you can bring those forward and you can do all the different pieces there. And then we can start to ask like real questions, right? So here's a question we want to ask: find all the vacant parcels in Austin, Texas that are in a designated opportunity zone. It will go through that, and then it will actually say, here's the query that you want to run to do that. And it's generating some, some SQL here that can be then passed into our MCP. I have not run anything yet. Again, this is running a query execute. The tool is execute query tool example, and it's going to actually build an example query that we can run and then pull that in and generate that query. So it'll explain what's going on. Here's the data set. You can do that. We can also add a filter for doing that in 15 minutes, and it's going to create more complex SQL here. As we go on, we're going to continue to ask questions, remove any parcels in these flood zones. We don't want it in a flood zone, so we'll remove those here. It's going to add that logic right down here. Oh, clicked into it right here in this line. So it's not in these zones. And we already know that we can pull that out because we've explored the data. We know where the columns are, or I should say that the MCP knows where the columns are and the AI does. So it's pulling that out. And then basically it's explaining like, these are the zoning types that, are within these flood zones. So A is a mandatory flood insurance. AE is a 1% flood with base elevation. So it's the same as A, requires drive construction cost, and VE is the coastal high hazard area, which in Texas, I don't think there are, or in central Texas, there aren't any, but at least that's what they are. So you can also test this against the Wherobots MCP and run these queries here. We're going to do that. It's going to continue to build this query out and construct it in a way that we need to with each of these different pieces. So for the remaining parcels, I'm also asking it to check how close it is to the nearest power substation and if it can support mixed use development, right? So we want, a large power source nearby. It's pulling that in and running that. And then we can actually do some demographic enrichment in these pieces. So it's continuing to build this query that it eventually is going to run, but we can construct this in the MCP without actually running in anything until we need to. But it's using all the logic from the documentations and stuff like that. So we can actually do that and keep kind of going from that perspective there. Okay, let's keep going here. Let me just actually pause, see if there's any questions from the group here. I'm just kind of keeping an eye on the various chats that we have going on. Is there any other questions so far? Wait, did I see one? Nope. Okay, cool. So let's keep going. Now I can basically move down here and tell it to rank all of these parcels. So it's built all this complex SQL logic. Now, knowing all these things about these parcels is great. That's helping us kind of construct and build this out. You see here, it's getting our substations, all this stuff in a very efficient way, all based on data that we already have ingested. Here's how the score is built. So it has a formula for creating a median income signal, home ownership rate, vacancy rate, education rate, and then all these different pieces here. And then it will actually go through and run this for each qualifying parcel. Figuring out the climate risk overlay. How many confirmed severe weather events were there within 10 kilometers over the last 5 years? Damaging wind reports. We can just ask this in plain text at this point, because at this point we've seen what has come back from the MCP in terms of what data is available, how we can use that and stuff like that. And we can, if you want to get in the technical weeds of it, you can do this validation of the SQL here and what can happen. So you can see here that it now has the storm events within the 5 kilometers. Here's the hail signature over at least 1 inch, the max hail size in that area in 10 kilometers, the wind event types and what's happening, and then basically summarizing all that in a storm risk score for that specific area for that parcel. So we're getting to kind of recap here, we're getting everything from demographic scoring. We're getting, parcels within certain facilities, restaurants, gyms, grocery stores, if they're in a climate risk area based on definitions that we've pulled forward, and we pulled that. And then we're, basically figuring out proximity to, other pieces in terms of, hospitals, FEMA flood zones, power lines for mixed use development and stuff like that. So we've figured out all of this. Here's the last one that we're pulling in, which is I believe it is so here's the parcels that were within near a tornado. And then finally, parcels within a 10-minute drive time of the Foursquare POI data, which is another open data set that we have. So that includes things like grocery stores and all the supportive stuff that you would want in those areas to support like a mixed use development. And that's kind of the case study that we're starting to build today. So it gives you all the logic here. Here's restaurants, gyms, grocery stores, stuff like that. We can use the drive times that have already been built, and we can kind of reverse engineer that to pull those data sets in from where we are in the parcels and things like that. So now what I want to do is actually build this as a complete notebook, right? So I want to explore this data in one place. And you can see here that it's built this notebook structure. It's sets up to connect to Wherobots directly. And I can run that complete notebook over here in this. That's not the white one I want, right here. So what this does, it allows me to explore this in different areas that I might want to. So you can see here, I built a notebook. I can now take this and run this. It has all the SQL logic. It's connected into our docs. It's written it efficiently, and it will go through to figure out all of these different components in the pipeline. Where are the vacant parcels that are within 50 minutes of a drive time outside of these flood zones? What's the distance to the nearest station, ACS block group enrichment and composite score, NOAA 10-kilometer storm events, tornadoes and severe thunderstorm exposure over the last 3 years, amenities within a 10-minute drive. We're also figuring out elevation and slope. We're adding in, understanding kind of, potential flash flooding, rain risk, development, costs, stuff like that. And then a final composite score. So what this does, I do my library imports. I'm connecting this to my runtime. And I can actually start building this out here. So I've set up a Wherobots runtime. I have that here, and that's going to connect in. And then I can actually just start running this notebook, which has been generated by the MCP right from my computer, which is great. So it's going to connect to my remote Wherobots runtime. I've set that up at a medium level, so I can do that here. You can see I'm connecting in here. And then basically I'm ready to start running this process and testing out to see what I get back from that. So if you're a technical user, you can do this here to do all these different things and, start writing the code and do that. But let's say that now you're happy with these results and you feel comfortable with it and you want to run this as a report on a daily basis. Now you can actually start to do that at a regular basis with what's known as a job. So as this is running here, I just want to show you kind of what that looks like in terms of an actual production job. So you see here, this is on the back end. This is my runtime that I'm running here. I'm going to go to the stuff that I've been running. So if that is, let's go to last 7 days. Everything that I've been running and testing here. You'll see here that this is some of the testing that I've been doing here and building out. And then I've actually been running this as a complete job, which is right here. So what this is it ran for 7 minutes. It ran that production job, or about 6 minutes and 14 seconds. And then I basically told it to turn that notebook into a production job. And I can run this on any frequency as that weather data is being updated, as if there's any of the other data that's being kind of consumed or pushed through. You can actually go through and start to build this out into a production job. And I can tell it now to run every week, or maybe I can trigger it through the command line to say, now run this analysis over in Florida or something like that. But it's built all the same logic and I have all the data covered there. That's really the advantage here, is that we can scale to any place where that data exists. So you can see here, I've turned this into a job. How did I do that? That was all through the command line over here. So if I go through what's happening here, I asked it to actually build this job and run it through the CLI. And what is really cool about this is it takes this whole logic that I built all in this notebook here and then turns it into a production job. Now, normally, if you did this, kind of by yourself, you would have to build that out, the job, upload it to your Whereabouts account, run and test it and stuff like that. But what it really did was it allowed me to actually go through and run these tests repeatedly here. And it kept running, reviewing, fixing, editing. This is all the stuff that's happening here with really just me reviewing and looking at what it's giving. You can see here that it was taking too long at the smaller scale. We moved it up to a medium runtime. And here we go, job completed. And the final data is ready to go. So we can actually see here that it's right there. Here's the code. Here's the data set that came out of it. Here's everything here. And if I wanted to take this out and turn it into a GeoJSON, and you can see here that these are the areas that have the best scores for us in San Diego, Phoenix, and Riverside. These are our best fits. And we actually have that entire thing going here. And it fixed, even corrected some of the SQL to like make it more efficient. So here's some different things that made it a little bit easier to pull this in. It moved it over to Phoenix and Riverside because that's where our sample data sets were. And then it moved up to from tiny small to medium because it's running on a much larger area. And then we can actually turn that and tell it, hey, Whereabouts run operator, run this every single week for me, which is what I love about doing this. It's just like building all of that out and stuff like that. So a few different questions here. How hard is it to get started with this kind of workflow? Can you get started with a free account? Yes. So you can sign up right now. I'm going to include a link after this for everyone that signed up. So you can go ahead, sign up. There's a 30-day free trial that you can get started with, and you can do everything that you're seeing here. So you can actually go in and prompt these things and build it yourself. If you need help with this, as a part of this too, we are offering sort of a kind of code along type session to help you get up and started. So if you sign up for that trial and you were here watching this, we can go ahead and set up like a 30-minute session with you to help you get started and set all that up. So whether you're running this for site selection, which I'm assuming a lot of you, if you're here, you wanted to do that, we can help you do that. And that's something we can do. So we'll send out the information and I can kind of show you how to do that. But you can get started with the account to do this. And then if you wanted to run this on a repeated basis after the trial's done, you would have to upgrade to a paid account. So that's where that would go from there. If you want to do this analysis for data center locations, there's no existing job that would do that specifically. So you would have to do that with the same logic that you want in. But there's a lot of existing data there. You may need to bring some of your other data in, like if there's specific things that you want to have, like existing data center locations or stuff like that. But what's cool about the MCP is that you can say, okay, I have this data at this location, or I know that it exists, help me do that. And I've actually built production jobs to move in different things to move that in and build that from there. So if I said, here's the data set, it's on this cloud bucket, it's in this location, I can actually move that over and go from there. What's the cost of a paid account for an individual that's not part of a company? There's different levels. So we'll send over some information on that, but there's different levels that you can scale. You can, go pay as you go, or there's like an account that allows you to do it at a very specific scale. So I'll send over all the information on that. So if you have some questions on that, I can send that over. Yeah, no problem. So there's a lot we can do here, and we can see here, let's just go ahead and look at our data. So you can see here, I have my site. I actually built out 3 data sets here, which is really cool. I have my site screening weekly, which is pulled in 2,500 rows. There's alerts that will tell me if there's any specific alerts, like things I want to be aware of. And then here's the top 20 history, right? These are the top 20 sites that I want. So we can actually go in here and see the data. If I go over here and go back to Data Hub, Whereabouts, it's in this bucket here, and you can see that I have my complete data set here, and it has all of this different scoring information and stuff like that that's ready to go. So that's one really great way to do that, especially if you're used to coding assistants. But what I also like, and something that we're also working on, is bringing this directly into different AI tools. So I basically here connected this into Claude and pulled in our MCP. And you can see this in just a pure chat interface, which I also think is really powerful and valuable. So you can see here, I'm doing the exact same process, going step by step, and it's giving me a heads up that, hey, our sample data is available in Arizona and California. So we're going to pull that in and switch our focus to Phoenix. It's going to see and figure out here which is the opportunity zones. Phoenix has 93,000, or I guess Arizona does. And here's the results that it has. So here's all the parcels that fall within an opportunity zone. It also has our flood zones, which you can be aware of, and it's flagging those in a very readable format for me. So that's my first step, right? Here's some different things I want to be aware of with the data. And then I can move to step two to find all of the areas within 15-minute drive time. So it's going to find that. It found the overture category for hospital. Um, and then it can actually pull all that in and says, here's the actual hospitals. Here's the, the different sites that are now filtered. These are all the ones that are still within, that 15 minutes of that actual hospital. And you can see here that all these are available there. Um, so there's a question: what platforms did you use spatial analysis based on? It's based on the instructions that I've given it. So it's not based on a specific platform. It's doing these queries as it's building them, right? It's using my logic that I built into the prompt to do this, to construct it in the way that I want to do it. Right now, we have the data I'm demonstrating with is open data, but if you had your own data, you could bring that in as well, and you could do all of the same stuff and all the same logic here that you're seeing me do, but with your data or your information or the data sets that you want to bring on board. And that's probably something that most people will be interested in, is actually figuring that out. So you can check that out here. There will be a video presentation shared as well. So we'll share that over as well, and we can do something similar. Happy to do that. And then what we can do here is move to step three. We want to figure out the infrastructure components and figure out the different tables here. So we're finding the data in OSM. It's all the power grids that are inside of OSM, which exists there. And you can see here, here's the circuits, and then we have the power infrastructure for all of those different parcels that we all cared about. So these now we basically have another layer that we're adding on with the power parcels. These are the nearest substations to each of these parcels. These are the size of them. Here's the distance in miles. You can see that a lot of these are much closer than others. And then here's the nearest line, and here's the distance to the line. So I get the substation distance and the line distance, another important thing. So this is the best one that's electronically connected. There's some of that that are unnamed. And again, if you have your own proprietary data, you can bring that in as well. Here's what I went through here. I pulled in the demographic enrichment. So you can see here for each of the parcels, here's the household income. Here's the average home value based on census data, home ownership percentage, vacancy rates, stuff like that, unemployment, bachelor's degree, all these different pieces. So it did this full demographic enrichment for me. And you can see all these different pieces where these parcels are strong fits and based on my criteria that I gave it. I basically prompted this whole step out here to do this. The key is that now, instead of the AI guessing, I'm giving it the data, and it can just write the queries against it. So there's something that you can do here very, very, very efficiently. NOAA storm risk scoring. So now I'm doing the same thing here. You can see it's using the correct spatial SQL under the hood. It's doing distance spheres for a 10-meter box buffer around Phoenix. And then here's all of our parcels, and then here's the different ratings here. And it's giving me just this output so I can scan this visually, which I like as well. If you know, there's two different environments to do this in. But you can see here, here's the hail size over 1 inch. These are the areas that have lower hail overall. Some of these have a lot as well. And you can see here, here's the wind, and then they are also good in terms of severe warnings, right? So these are some of these lower areas. So now we have another component to add to our score. Step 6 is we're doing our amenity scoring. So you can see some of these here are very close to restaurants, coffees, and gyms. And you can kind of see how that breaks out for each of these. Some of these are very close to restaurants, but some of them are basically in the middle of nowhere, and there's no amenities near them. Another important factor as we're deciding. So then we take our fit scores. We give it an amenity score. These are some of the best fit for demographics. Here's the best fit for lower storm risk. Here's the grid proximity. And then I do, right now I'm running my composite scoring that's happening under the hood. And if I open this up, you can see here that it is basically taking all this data out. It is running a query each time. So if I go back here at any of these steps, you can see the queries that it's running. So if I go in here, describe the tables, architect the queries, execute the SQL. It's doing the same thing we did under the hood, just all through the chat here. So my last step is I'm building out my final scores, and it's telling me that these parcels are my best fits right here. These are the different ones that based on this analysis that I can rerun and see. And you can see here's my composite scores for each of these in these different areas. And then what it's doing under the hood here is actually building a simple dashboard to show me that. So we can tell it to build a Map Libre dashboard. I'm just going to say build a simple HTML report with a simple map in it to show me the results. And this is Claude doing this. It's just pulling in GeoJSON and doing some data transforms here, but that allows me to do that. So the question was a few different things. Has it been done for nuclear regulatory? Uh, not that I know of, but it's certainly anything. You could do any of these things for these different pieces, right? This is kind of the fun part about this is that we're combining your knowledge and logic using the AI to do the orchestration, and under the hood, the MCP is being the power to drive all of that. But the most important part, and probably the hardest part about doing this with AI is like you have to have that data and query logic all set up and ready to go. And that can be a particular challenge if you don't have that together. What Wherobots brings to the table is the computing power to do this, to help you scale that up and do that at any global point on the globe. We have the open data to get you started. And then we have the support to help you bring in your other data sets that you want. And we're adding lots of data to bring this forward to do this spatial analysis at scale. So there's another question about API calls or pipelines in MCP to make the location analysis available to the agent or LLM. So that's what I was showing here, is that under the hood, what we're doing through our Wherobots MCP is basically right here. We can describe data that's in our catalog. So it's telling me information about the metadata, when was it updated, the frequency, all those different things there. It's not an API call, so we're not calling out to a third-party service. We're just basically using our MCP to explore the data, look against our documentation to see what functions it should use and what's available. So you get the full knowledge of everything that's in our documentation, the functions that are available, the efficiencies to write the queries against the database, all the stuff that is, historically hard to do. And then finally, it's actually creating and assembling queries. And then for developers, you can build out notebooks to test this out. And then I can convert that into an actual job, which is here. So I have this as a full production job that now I can go ahead and run. And our CLI will allow me to do that and push that into production. And you can see that that ran in the background there, and I have that data available. So that's what's happening here as well, is all of these are doing the same calls to reference our docs, logically construct and build queries. It is allowing you to view the catalog and see what data is available, actually execute queries, which is what's returning data here. And then finally, actually, if you wanted to, you'd have to then code to productionalize the jobs and stuff like that. So it's building me a HTML file here. That's the final step to kind of see all this information out. And Claude's helping me do all of that so I can just see what's available. And then I can kind of take that forward and scale it from there. But the key is that the other thing that we're starting to add in are specific skills to do this, be it for data engineering processes, do it for specific types of complex joins or stuff like that, and things like that. So to make the MCP run smoothly, do you have to set it up with data first? Generally, if you have your own data that you want, yes, I would recommend doing that. We have open data out of the box, so you can actually use Overture maps and Foursquare data. We're adding more data. Some of the data that you saw here is preview data that we're going to be pushing into our open catalog. So things like the weather events, the other pieces like that. For the example, like with Regrid, that's a data partner of ours. So if you actually wanted to load that data in, you can do that and just request that from us through a different account and set that up so you can ingest professional data and stuff like that at a different tier. So there's open data you start with, there's your data, and then there's I guess premium data that you can onboard and use that. But out of the box, when you sign up, all the open data is there. And then if you want to load in data, you know where data is. You can use the MCP to build that job and the CLI to productionalize that job, and you can do all those different pieces there. So you can build all those things out. Let me see what else is here. Do you need a professional enterprise account to do this? Yeah, so you need a professional account. You can sign up for that and get that. That's where that 30-day free trial comes in. So you can go ahead and sign up for that account, and then you can kind of pick your sizing after the fact about what size you want to go to from there. So then you can do this in a production scale over every single month. And then we're releasing. This is the preview of the integration with Claude, which we're releasing soon as well. So you can do that there. What about data from Claritas? We're working on building out our data partner network, but if you have those in flat files and you want to ingest them, by all means, you can do that with, Dun& and Bradstreet, you know, demographic data, premium data sets and stuff like that. But we're increasing to build out our data, our data catalog with premium data partners as well. But if you have it, again, just wherever that data is, you can build that out. And here is our Phoenix Opportunity Zone score. I have to actually open this in a browser because it won't read that in the desktop app. So let me do that here and get my browser window, which is somewhere here. Oh, it's hiding behind here. Okay. And this is our final report. So as you can see here, this is telling me that there are 20 vacant parcels of 2 acres, quality opportunity zones, can, blah, 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 built all this out. And you can see here are all the acres. Here's the average composite score. Here's the income, and here's the total assessed value. And these are the polygons that it's telling us. The darker ones are the higher value ones. So if we zoom out here, we can see these individual parcels out here. I can click on them, and it's going to tell me that this is the specific value here. And it gives me I love this. I love the visuals it creates because it gives me these component breakdowns. This is the elevation score. The CLM should be and I can actually click and see that here. So if I go up here, here's my composite score, 50.47. You can see it's acres. Here's the zoning, household income, home ownership percentage, and here's the amenities, 2 within 2 kilometers. So it's giving me some of these different scores. Here's the amenity score, which this one is much higher. Here's the breakdown in terms of, I think this is like some of the different things, geodemographics, climate, amenities, demographics, climate, and the grid, which is the electric grid. So you can see that this one's there. This one scores really high on these threes, but there's nearly no amenities. And if we look, it's pretty isolated out here. As you can see, it's sort of vacant land in this area, but that's where a lot of these high scoring ones are. If we move here, maybe into a more central area, we can see here that this is still scoring high. It's proximate to a lot of amenities, but the demographic breakdown is not what we're looking for. And you can see there that a lot of that falls in that category. So we can filter through all these different pieces and go from there. Yeah, I mentioned MapLibre and Leaflet, so you could point this into you could point this into Claude Code and build out a custom application. And that's the other step I was going to get to today, but I think I quite get to that one. I wanted to show it at least just through the general chat here. So you can see you can build like basically a fully, built out, simple dashboard application. But if you want to build something more robust with MapLibre and Leaflet, you basically can connect the MCP into Claude Code and have it extract the data from the job, download it, and read it there. So just to give you a simple visual of what that looks like. But these are our top areas here. Can I elaborate on the top 2 items in the list? It looks like climate scores are pretty different from each other. So if you see here on this component breakdown column, there's the green, which is amenities. There's the DEM, which is demographics. The CLM is the climate score. And then the GRD is the grid or electrical grid score. So you can see here that it varies quite a bit there. The climate score also actually varies quite a bit. This one didn't really have many events happening within the climate score. So that's kind of interesting to see what was happening there. But as I can click on that, I can see that there's, I can look at the storm risk, and then if there's, substations nearby, all these different pieces and stuff like that. So that gives me this different view about all the top ones that are there. It's the ability to generate these sorts of dashboards with Claude and MCP available today. The ability to generate the data and do all of those things that I did with the MCP is available. And then we are finalizing our release to do this all in Claude with our MCP in the coming weeks. So this is just a preview to show you what's coming here. And then you could do everything you saw today right out of the box. We're at the key things that are coming soon are the direct cloud integration. So you can just basically go in, add it at Wherobots as an extension and start doing this stuff, and it'll just start working out of the box. And then more importantly, the second bit is we're adding and bringing in all of these open data sets. So I'm actively pushing in more and more data. So you'll be getting more open data out of the box that you can start with, things like these storms and stuff like that, all the stuff you're seeing here. We're adding in more data that if you wanted to get like a premium data provider, you can bring that in as well. And that would just be through a separate kind of add-on. And then your data, whatever data you have, you just bring that in and do that here. But the key is that I can use the MCP just to say, here's my data, help me bring it in, create a table, create a job, update it every day, and then you're good to go. The climate is referring to a few different things. So that's flood zones, but also all of those storm risks that we talked about earlier. If I go back to Claude, the chat, close this out for now. If I go all the way back to those are the amenity risks. These are the storm events. So it's climate, which includes flood zones, but also hail. TVS, I believe, are the tornado vortex signatures. Then there's hail, wind, storm warnings, and severe storm warnings that are, or tornado warnings and severe storm warnings. So it gives you that from publicly available data that NOAA publishes that goes all the way back to 1955. So, or maybe even 1950, but yeah. Yeah. Any other questions from the group here? All right. So with that, we'll kind of leave it there for today. I'm going to send out a bunch of information after the fact. The cost per analysis, the pipeline I ran today, once it was there's some cost for doing some of the testing that it had to loop through, but that specific pipeline that I ran, and just to show that I'm being transparent and honest here, let me just open this up so I can go to my workload history. Let me just pull in just my stuff here. And you can see the final one was right here. And that took, once it loads up, I think it was like just over $8 in total to run that whole thing. So, yeah, $8.77. So that's what it took to run that. And there's some testing costs when you saw it was doing some of those corrections and calibrations. Like we try to get the generating the SQL query to handle as much of that as possible. So it gets rid of most of it. There's a few things that it will have to adjust. So there's some testing costs, but like this is pretty much what you'd expect to run this if you wanted to run this every week. This is more or less what it would take to run that in that specific area. If you go to a wider area and stuff like that, you may need a larger runtime. It may take longer. So there's some other things to be aware of there, but the key is that we did so much work to make the spatial engine as efficient as possible. And we're looking at going across, I mean, how many different data sets here? We had demographics at the block group level, census, that's the block groups. We pulled in the 15-minute drive times across the entire Overture Maps data sets. We pulled in all of the property parcels, the entire storm's history from the past 3 years, created buffers on those. I'm missing some here as I'm going along as well. The Foursquare POIs, and this analysis, I believe, did it for the entire state of Arizona and California. So it did it. The first one did Arizona in Claude Chat. This job that you're looking at here did it for the entirety of California and Arizona. So just to give you some idea of scale there. Yeah, there's cataloging under the hood, Chris, to point that out. The queries are super efficient. We did do a lot of work to make this the best option there. There's under the hood, if you go to Data Hub here, we actually use Iceberg. So it's very similar to a spatiotemporal asset catalog, but here you can see I actually have this is the Copernicus DEM, and this is a global 30-meter elevation model. So you can see here it's actually reaching out to raster files for a raster example, but I can stream in just the pixels that I need. So for those small properties, I'm only pulling those pixels when I'm at query time. And this data, I'm actually pulling it in from the public S3 bucket. So it's basically just a pass-through catalog here that's going there. For the demographic data, like the US ACS, this is that block group summary table that I constructed. To be clear, I pulled this in in half a day using the MCP and the CLI. and I was able to build this table. So you can see here, this is 242,000 block groups in the US. It's from the 2024 American Community Survey, which is the most recent release. So you can pull all that in there, and the whole thing is that all the way down. If you want to get into the weeds of how all this stuff works, we make it super efficient to pull that in and do that at scale. So I chose block group. I think block groups just some people use tracked, but I think block groups gives a little bit more granularity. But we're eventually adding all of those as well, so you can pull those in. But yeah, that was it for today. Lots of great questions here. If you would like to try it out, you can go ahead here, go ahead to click try Wherobots. I think that's actually just going to take me to my account. You can go ahead and get signed up. That'll get you into your pro trial, which you can go ahead and use for 30 days. And then if you're interested, I'll send out an email with all this information so you can do that. We're offering that kind of like 30-minute kind of fast tracked onboarding to get you started if you sign up for that trial. We'll help you get set up and get you what you need, and then we can kind of help you from there. And I'll send out all the information to get that set up. So if you're interested in that, you can just reach out to us or reply to that email, and we'll take it from there. But yeah, thank you for joining today. Lots of great questions. Hope to see all of you jumping in and testing out Wherobots. And yeah, we'll take it from there. So thank you.